The Stonehenge Code, revealing its 10,000-year-old secret.
Introduction. Recent carbon dating from the bluestone quarry sites offers compelling and irrefutable mathematical evidence that Stonehenge's construction dates back to the Mesolithic era. This new data suggests Stonehenge is 5,000 years older than experts had previously believed, challenging established views on its origins and adding new depth to our understanding of this ancient monument. Papers by researchers from the University of London, Southampton and Manchester, including Mike Parker Pearson and his team, have significantly advanced our understanding of Stonehenge's origins. The discoveries at the Craig Rossifalin quarries and the bluestone megaliths at Carn Godog, which reveal that Stonehenge may have been initially built in Wales and then transported to Salisbury Plain 500 years later, are no longer credible. This groundbreaking revelation has captivated archaeologists worldwide and challenged previous beliefs about the construction of Stonehenge. The idea that these bluestones were quarried, shaped and then moved to Salisbury Plain offers a deeper understanding of prehistoric people's capabilities and social organisation. The transport of these massive stones over such a distance, centuries after their initial quarrying, suggests remarkable dedication and coordination. It highlights the profound significance these stones and the monument they form held for ancient communities. As an enthusiast of ancient civilizations, I find this research thrilling. It deepens our appreciation for the ingenuity and spiritual dedication of our ancestors, opening new avenues for exploring cultural and religious connections across prehistoric Britain. Craig Rossifalin. The December 2016 edition of Antiquity magazine featured a report titled Craig Rossifalin, a Welsh bluestone megalith quarry for Stonehenge, unveiling intriguing insights into the origins of Stonehenge's bluestones. The study identified a 4-metre-long monolith at Craig Rossifalin as microscopically identical to Stonehenge's bluestones, ignited substantial debate and speculation in the archaeological world. However, the report's emphasis on 2 radiocarbon dates, which aligns with the author's hypothesis on Stonehenge's construction, has raised concerns about the completeness of its narrative. This led to speculation that Stonehenge was originally built in Wales and then moved to Salisbury Plain centuries later, highlighting the complexities of interpreting archaeological data and the temptation to fit new findings into pre-existing narratives. A deeper analysis of the report reveals a trove of Mesolithic carbon dates from human-made halves, suggesting a much earlier period of human activity at the site than the highlighted Neolithic dates. These Mesolithic dates, which predate the current understanding of Stonehenge's construction, were largely overlooked in the public dissemination of the study's findings. This oversight highlights crucial questions about the narrative surrounding Stonehenge's origins and the methodologies used in archaeological dating. The presence of Mesolithic halves at Craig Rossifalin indicates the site's significance to human communities millennia before the Neolithic era. This evidence challenges the conventional timeline of Stonehenge and suggests a more complex history of human interaction with the landscape and its bluestones. Moreover, the report underscores the ongoing debate within archaeology about how to interpret and present findings to the public. The focus on headline-grabbing narratives, such as the relocation of Stonehenge from Wales, can sometimes eclipse equally significant but less sensational discoveries like Mesolithic activity at the quarry site. Stonehenge Old Car Park The 1966 excavation and subsequent discoveries surrounding Stonehenge offer a fascinating and somewhat contentious insight into the challenges of accurately dating ancient sites. Initial observations by Lance and Faith Thatcher revealed 3 holes near Stonehenge with a Neolithic character, though no datable pottery was found. Yet the characteristics of the holes suggested a Neolithic origin. This assumption was later challenged when a PhD student discovered that the charcoal deposits from these holes, composed primarily of pine, could not be Neolithic, as pine was believed to be extinct in the area by Stonehenge's supposed construction based on pollen analysis. This revelation was startling, particularly to officials from the Historic Buildings and Monuments Commission, now known as English Heritage. Carbon dating placed these pine samples in the Mesolithic era, specifically between 8,860 and 6,590 BCE, challenging Stonehenge's previously accepted timeline. Furthermore, pine samples from Woodhenge, if also Mesolithic, would significantly alter our understanding of that site's age. Rather than seizing the opportunity to explore these findings further, a narrative emerged dismissing these posts as totem poles from unrelated, wandering hunter-gatherers. This decision to sideline potentially groundbreaking evidence highlights a reluctance within certain segments of the archaeological community to reconsider established narratives even when confronted with new data. The 1988-89 discovery by Wessex Archaeology of another Mesolithic post hole, along with a piece of rhyolite dated to 7,737 to 7,454 BCE, further complicates the timeline of Stonehenge and its surrounding areas. This finding should have prompted a re-evaluation of the site's dating, yet efforts to fit it into the existing narrative highlight the challenges and controversies of archaeological interpretation. These instances emphasize the need for openness, curiosity, and a readiness to revise our understanding of history as new evidence emerges. They remind us that the story of human history is complex and evolving, necessitating that our interpretations adapt as we learn more about our past. Discoveries at Stonehenge, including charcoal OXA-18655, found in the hole socket of stone 10, dating back to 7,330 to 7,060 BCE, align with the dates of the Mesolithic post holes, offering significant implications for our understanding of the site's history. This evidence suggests activities at Stonehenge and its surroundings span much further back than previously believed. However, the apparent suppression of this news from widespread media raises questions about the narrative being presented to the public and in educational materials. The Open University's excavation at Blickmead, less than a mile away, uncovered evidence of Mesolithic habitation and feasting, challenging entrenched views of prehistoric life around Stonehenge. These findings suggest a continuous and significant presence in this area during the Mesolithic period, contradicting the simplistic totem pole myth perpetuated in some narratives by English Heritage (EH) exhibitions and guidebooks. Moreover, the recent transformation of the Stonehenge site, including the closure of the B road past the stones and the relocation of the visitor car park to a new multi-million-pound visitor centre, signifies a significant shift in how the public accesses and experiences the site. The removal of the old tarmac and restoration of the land to grass aims to restore a more authentic prehistoric ambience, highlighting the tension between modern interpretations of the site and emerging evidence of its ancient past. Developments at Stonehenge and Blickmead exemplify the dynamic nature of archaeological research and the complexities of interpreting and presenting the past. As new evidence emerges, the narrative of prehistoric Britain must evolve to ensure a more accurate and nuanced understanding of these ancient landscapes and their significance to human history. And you'd think that removing the tarmac from the old visitors' car park at Stonehenge, especially given the previous significant findings beneath it, would lead to a comprehensive excavation to uncover more evidence about the site's Mesolithic history. Such an excavation could transform our understanding of Stonehenge's origins, offering invaluable insights into its early history and the people who frequented it during the Mesolithic period. Tim Dawes' role as a warden at Stonehenge and his proactive documentation of the site's changes and features through photography exemplifies the kind of engaged observation that can lead to significant discoveries. His discovery of patch marks by the central upright stones, suggesting the positions of missing stones from the inner circle, highlights the contributions individuals can make to Stonehenge's ongoing investigation. Dawes' work underscores the importance of continuous, attentive observation of archaeological sites, even by those not formally conducting research. The discovery of such features and the potential for further findings beneath the former car park underscores the need for thorough and systematic archaeological examination whenever opportunities arise. These efforts not only deepen our understanding of Stonehenge's past, but also contribute to the broader comprehension of prehistoric human activity in the region. As we peel back the layers of Stonehenge's history, each finding adds another piece to the puzzle of this enigmatic monument story, emphasizing the importance of preserving and exploring our archaeological heritage. Tim Dawes' experiences and observations as a warden at Stonehenge, particularly his discovery of additional post holes beneath the old visitors' car park, highlight the continuous potential for new findings that can challenge and enrich our understanding of Stonehenge's history. Despite being warned against publishing his conclusions due to unauthorized blog activities, Dawes chose to resign and continue his work, revealing through unofficial pictures the existence of more post holes under the car park, aligned with those discovered in 1966. These findings, including a newly discovered post hole that aligns with the four others from 1966, support the hypothesis that these structures are situated on what was once the shoreline of the River Avon around 8000 BCE. This suggests that during the Mesolithic period, stones quarried in Wales could have been transported directly to Stonehenge via boat, navigating through enlarged rivers rather than taking the longer sea route proposed by some archaeologists. Welsh bluestones. Further complicating the narrative are analyses of the bluestone structures from other Preseli sites like Carn Gwydog and Craig Talfinid, which are connected by streams and rivers to the River Nevern. Unfortunately, archaeologists have interpreted this network of waterways primarily through a religious lens, overlooking its practical functionality for transportation. The persistence of the ox cart route theory, which proposes a land path following the modern A40, overlooks the logistical challenges posed by the period's dense woods, swamps and forests. Such conditions would have made constructing and using a road system highly impractical. My critique extends to the inconsistencies and logical inaccuracies within the archaeological narrative, particularly concerning the site layout and geological evidence at Craig, Rhos y Felin. The assumption that floodwaters in the area were solely from ice melt, quickly draining into the sea after the Ice Age, overlooks the broader implications of such flooding for the landscape and its inhabitants. We confirm within the report that an old river once ran around this quarry, dating back as far as 5,620 to 5,460 BCE and possibly up to 1030 to 910 BCE. To quote the report, most of the site was then covered by a layer of yellow colluvium, dated by oak charcoal to 1030 to 910 BCE. This deposit is contemporary with the uppermost fill of a paleo channel of the Brimberian stream that flowed past the northern tip of the outcrop. Charcoal of Corylus and Tilia from the basal fill of this paleo channel dates to 5,800 to 5,640 BCE. The report suggests that during the Mesolithic period, an enlarged stream feeding into the River Nevern extended to the quarry outcrop rocks, remaining just a few metres away until 1000 BCE. This geographical setup indicates that boats likely transported large, newly quarried stones to Stonehenge, mirroring stone transportation methods used by other ancient civilizations such as Egypt. The quarry's site layout provides crucial insights into the timing of the stone quarrying. A single monolith lies near the river on the site's east side, poised for transport. Nearby to the south are human-made halves, suggesting their expected placement. However, the dating of these halves as Mesolithic with three identified periods, 8,550 to 8,330 BCE, 8,220 to 7,790 BCE, and 7,490 to 7,190 BCE poses a challenge, although the report claims that no evidence of Mesolithic quarrying or working of rhyolite is present at this site. This claim overlooks the practical use of tools across different periods. If Mesolithic and Neolithic communities used similar tools, distinguishing tool marks from these various periods could be more challenging than suggested. Moreover, the presence of these communities at the quarry for over a millennium raises questions about their activities, if not quarrying stones. The connection between the quarry site and Stonehenge is reinforced by over 20 carbon-14 dates that support my hypothesis, in contrast to the two samples highlighted by experts, which were dated 300 to 500 years older than existing estimates. By analysing these overlapping dates with the latest carbon dating curve int cal 20, we can refine the construction date of Stonehenge's Phase 1, the placement of bluestones in the Aubrey holes. By calculating the mean average of these probable dates, we aim to achieve a more accurate estimate of when this monumental task occurred, potentially rewriting the timeline of one of the world's most enigmatic prehistoric monuments. As you scroll through the screen, the number of C14 dates and their correlation is immense. A full printed table is available on the blog. Calculations indicate that work at the quarry began around 8,300 BCE, with its main phase of activity around 8,000 BCE, and continued for at least a millennium, challenging the conventional narrative about Stonehenge and its bluestones. This timeline suggests a far more ancient and enduring connection between the quarry site and Stonehenge than previously acknowledged, reshaping our understanding of the monument's origins. Carn Godog. Initially, Carn Menin in the Pressley Hills was believed to be the source of Stonehenge's spotted dolerite. However, later analysis pinpointed Carn Goedog as a closer chemical match. Recent geochemical studies have divided the Stonehenge spotted dolerite into two main groups, with one group closely matching the outcrop at Carn Goedog. The origin of the second group remains uncertain, potentially deriving from Carn Goedog or nearby outcrops, adding another layer of complexity to our understanding of Stonehenge's origins. Further geological investigations at Stonehenge have identified additional sources for its bluestones. Unspotted dolerite matches outcrops at Cerrig Marcogion and Craig Talfanid on the Preseli Ridge. Another variety, rhyolite with fabric, traces back to Craig Rosie-Felin, while a source of lower Paleozoic sandstone has been identified north of the Preseli Hills. The origin of volcanic tuffs found at Stonehenge likely lies in the Preseli area, expanding our understanding of the diverse origins of the monument stones. Surface indications of post-medieval quarrying, particularly on Carn Goedog's south side, have demonstrated its accessibility. This historical quarrying, distinguishable by cylindrical drill holes on some quarried blocks at the outcrop's base, was carried out using the plug and feather technique with metal wedges. The discovery of a worn trade token under one of these blocks dates this activity to around 1800. In 2014, test trenching along the southern edge of Carn Goedog revealed layers of human activity spanning various periods from recent centuries, as found in Trench 3, to deeper layers of prehistory identified in 2014 Trench 2. Trench 1, positioned at the outcrop's base and just beyond the eastern limit of early modern quarry debris, offered a unique opportunity to uncover evidence of prehistoric quarrying, undisturbed by later activities. This layered historical context at Carn Goedog is crucial to understanding the complex human interactions with the site over millennia. The evidence for prehistoric quarrying, undisturbed by post-medieval activity, provides invaluable insights into the methods and technologies used by ancient peoples to extract and transport stones that contributed to the construction of monumental structures such as Stonehenge. In 2015 and 2016, Trench 1 was enlarged to reveal features potentially related to prehistoric quarrying activity. At the southern foot of the outcrop, an artificial platform of flat slabs, many of them split, was uncovered, laid with the split faces upwards in a tongue-shaped formation measuring 10 metres north-south by at least 8 metres east-west. Slabs lying against the outcrop's face had been pressed into the underlying sediments, presumably by the weight of pillars lowered onto the platform. The platform terminates with a vertical drop of 0.9 metres from the outcrop to the ground surface beyond. This platform predates a series of deposits, including early modern quarrying debris and halves from the Roman and medieval periods. One half, set in a gap in the platform where a slab had been removed, produced charcoal dating to 7,190 to 6,840 calendar years before present, 8,090 plus or minus 38 years before present, and 2,890 to 2,630 before Common Era, 4,164 plus or minus 30 years before present. The Stonehenge layer. The findings across the quarry sites, including Carn Goedog and Craig Rosie-Felin, suggest a nuanced understanding of how the bluestones were utilised and replenished at Stonehenge. The halves discovered at these sites, particularly those dating to the Mesolithic and Neolithic periods, indicate ongoing human activity and potentially organised efforts to quarry and transport bluestones over extended periods. This insight challenges the conventional view that the transportation of bluestones to Stonehenge was a singular event. Evidence of modern quarrying at both the northern and southern ends of these sites, along with dates from central halves, aligns with observations made at Craig Rhos y Felin. Our research, outlined in published books, supports the theory that ancestors chipped away at the bluestones at Stonehenge for healing purposes, possibly by bathing in the water of the ditch to cure their ailments, as evidenced by the Stonehenge layer discovered by Dervillin and Wainwright in 2008. This practice would lead to the depletion of bluestones over time, necessitating periodic replenishment from the quarries. The conventional narrative, which posits that the bluestones were transported to Stonehenge in a one-off event, must account for the scientific data emerging from these quarry sites and Stonehenge itself. The evidence suggests a more complex interaction with these stones involving repeated quarrying and transportation activities that likely spanned centuries. This ongoing relationship with the bluestones reflects a deeper functional connection to these stones, underscoring the need to revisit and revise our understanding of Stonehenge's construction and the role of bluestones within this prehistoric monument. AI verified mathematical model radiocarbon probability proof. We've rerun our radiocarbon work with an updated 3 sigma model, refining the original bluestone and Mesolithic dates from Stonehenge and the 2 Craig Rhos y Felin quarries. The revised assumptions and maths are presented here, with every sample's calculation listed in the appendix at the end of the post. To work out whether the Stonehenge post holes belong to the same Mesolithic activity that produced bluestone debris at Craig Rhos y Felin and Carn Cwdog, we ran a head-to-head test of their calibrated radiocarbon ranges. 1. 5 Stonehenge post holes dated between 8,825 BCE and 6,651 BCE once calibrated. 2. 27 quarry samples span 8,550 BCE to 6,840 BCE. 3. Overlap rule, BCE logic, a quarry date. Matches only when its whole 95% range is engulfed by a Stonehenge range. Remember, bigger BCE numbers are older. 4. Probability per match. For any given pair, we assume the quarry range could have landed anywhere within a 10,000 year window, and it's spanning from 10,500 to 500 BCE. 5. Odds stacking. Multiply every overlap probability that actually occurs. If no overlap, we drop that pair. Probability equals 0. Headline results, details of which can be found in the blog, whose link is provided in the description below. For each sample at Stonehenge, we worked out the odds of a match found in the Welsh quarries. Samples HAR455 had 12 sample overlaps, which gave a combined probability of 2.29 times 10 to the power of 11. This translates to a mathematical odd of 4.37 times 10 to the power of 10, which in English is a 43,700,000,000 to 1 chance of being a coincidence. Sample GU 5109 had 10 sample overlaps, which gave a combined probability of 4.419 times 10 to the power of 12. This translates to a mathematical odd of 2.27 times 10 to the power of 11, which in English is a 227 billion to 1 chance of being a coincidence. Sample HAR456 had one sample overlapping, which gave a combined probability of 7.70 times 10 to the power of 2. This translates to a mathematical odd of 1.30 times 10 to the power of 1, which in English is just 13 to 1 chance of being a coincidence. Sample QXA-4219 had 2 sample overlaps, which gave a combined probability of 3.38 times 10 to the power of 3. This translates to a mathematical odd of 2.96 times 10 to the power of 2, which in English is a 296 to 1 chance of being a coincidence. Sample QEXA-4220 had 3 sample overlaps, which gave a combined probability of 2.99 times 10 to the power of 4. This translates to a mathematical odd of 3.34 times 10 to the power of 3, which in English is a 3,340 to 1 chance of being a coincidence. Multiplying those 5 combined probabilities gives an overall odds ratio of 1 in 1.27 times 10 to the power of 29 that the observed overlaps happened by chance. In words, the chances of this being random and not a direct proof of association is 1 chance in about 127 octillion. So, do the numbers prove a Mesolithic Stonehenge? Statistical punchline. A 1 in 10 to the 29th chance is far beyond the customary 5% or even 0.1% thresholds archaeologists use. In lay terms, you're more likely to win the UK National Lottery 10 draws in a row than to get this pattern by random dating. Caveat's radiocarbon ranges remain probabilistic. Bayesian phase modelling or kernel density methods could shift the spans slightly. But even if the true spans were twice as narrow, the coincidence odds would still be well below 1 in 10 to the power of 20. Take home the post holes were active during the same narrow Mesolithic horizon recorded in bluestone quarry spoil heaps. That makes a causal link overwhelmingly likely, not a dating fluke. Interpretation in an archaeological context. This extremely high ratios suggests that the likelihood of such a match occurring purely by chance is extremely low, approximately 1 in 127 octillion. Here's how this ratio can be interpreted in practical terms. Strong archaeological linkage. This result suggests a robust archaeological connection between the sites at Craig Rosie-Feilin and Stonehenge. It might indicate that materials from Craig Rosie-Feilin were specifically used or chosen for inclusion in constructions at Stonehenge, or that there was significant movement of materials or people between these locations. Cultural or historical significance. Such a finding could have important implications for understanding the cultural or historical connections between these regions during the period in question. It may indicate a coordinated or planned use of resources, shared technological practices, or even broader social or trade networks. Further investigation required. Given the significance of this finding, it would likely lead to more detailed investigations. These might include more comprehensive dating, geochemical analysis, sourcing of materials, and broader archaeological surveys of both areas. Statistical robustness. While the ratio provides a stark indication of rarity, it's also crucial to ensure that the statistical assumptions behind this calculation are robust. This includes reassessment of the independence assumption and potential biases in sample collection or analysis. Conclusion. And so the numbers refuse to be quiet. When 5 independent sets of Mesolithic radiocarbon samples from Stonehenge and its Welsh bluestone quarries locked together with an overall probability of 1 chance in 1.27 times 10 to the power of 29, about 127 octillion to 1, the calculation does more than tweak a date. It detonates the chronology of British prehistory. Taken at face value, the statistics push back the first construction phase of Stonehenge to circa 8300 BC, a full 5 millennia earlier than the textbook Neolithic horizon that has dominated public imagination for a century. That shift drags a whole archaeological era in its wake. Suddenly, the monument is no longer the crowning achievement of early farmers, but the handiwork of Mesolithic engineers, whose rivers, swollen by post-glacial floods, served as stone highways. It forces us to reopen every anomalous charcoal fleck, every pine wood post hole and half dismissively labelled totem pole activity, and ask, were they really outliers, or the evidence of a sophisticated culture we chose not to see? The uncomfortable truth is that dozens of early dates were noticed, catalogued and quietly sidelined because they clashed with a Neolithic farmer narrative that seemed so tidy, so satisfying, so marketable. If the Stonehenge Code's math stands, the implications are staggering. Britain's megalithic story begins before pottery, before settled agriculture, before the very social models we use to frame civilization. The question is, in Aristotle, whether stray C14 readings were mistakes, but whether our own preconceptions have been the real anomaly all along.